Like I said, there's disjointed software, and you've got to build these one-off solutions of hardware in order to get it to work. And then there's another aspect of it is how do you actually do the computation? How do you get enough horsepower, computational horsepower, in the system to be able to do machine learning? So let's take a step back. So there's two different ways you can apply machine learning to RF systems, okay? So I mentioned before you have kind of the application layer. So this is your voice or your cell phone, surfing the internet, things like that. So if you have an RF system that can receive that data and it can do the machine learning or deep learning on it, you could actually just apply the machine learning to the application layer. Okay, so that's kind of your basic way to use what we're doing. But then the next layer up is how do you apply machine learning to the RF system's physical layer and to improve its performance. So to improve signal reception, to improve the ability to mitigate interference, stuff like that. And so in order to apply machine learning to the RF signals themselves, you have to digitize the raw data. So when your cell phone receives a signal and it demodulates that signal and turns it into data, that data content is actually less bandwidth than the RF signal it was itself. So we need to operate over here where we have the raw RF signal. So if you're on the top of a tower, say for instance, that tower may have fiber optic lines going back to the Verizon data center or whatever. But those lines are already dedicated to the data content. So if I want to do machine learning on the signal itself, I can't just digitize that and expect to use those fiber optic lines to get it back to a data center to do the computations I need. So the obvious answer is, well, then you got to bring it out to the edge. And this is the whole field, what we call edge computing. So that's bringing the computational engine out to the point where we receive the signal. And so that's the RT.